Effortless Hugging Face Model Deployment on AWS with Terraform and Serverless SageMaker Endpoints. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: Serverless NLP Model Deployment on AWS in Natural Language Processing. NLP, Hugging Face models have become the go-to resource for developers and data scientists due to their robust capabilities and ease of use. Deploying these models in a production environment requires a scalable and cost-effective solution. Enter Amazon SageMaker, AWS's fully managed service that allows you to deploy machine learning models at scale. By combining SageMaker's serverless endpoints with Terraform's infrastructure as code, IAC, approach, you can create a seamless deployment pipeline for your Hugging Face models. This podcast will walk you through deploying a Hugging Face model on Amazon SageMaker using Terraform. We'll cover everything from setting up your AWS environment to provisioning a SageMaker notebook, preparing your model, and deploying it to a serverless endpoint. Prerequisites: AWS account setup and Terraform installation. Before diving into the deployment process, ensure you have the following prerequisites in place. AWS account: an active AWS account with appropriate permissions to create and manage SageMaker resources, IAM roles, and S3 buckets. Terraform, installed on your local machine. You can download Terraform from the official Terraform website. Once you have these prerequisites, you can start provisioning your AWS resources. Step 1. SageMaker Notebook Provisioning with Terraform. The first step in deploying your Hugging Face model is provisioning a SageMaker Notebook instance using Terraform. This notebook will be your development environment for preparing the model and scripting inference tasks. Create a Terraform configuration file, main.tf, with the following contents. Provider AWS. Region equals us West 2. Resource AWS_SageMaker_notebook_instance Hugging Face_notebook. Name equals Hugging Face Notebook. Instance_type equals ml.t3.medium. Role_arn equals AWS_EOM_role.SageMaker_execution_role.arn. Lifecycle_config_name equals Hugging Face Lifecycle. Resource AWS_IAM_role SageMaker_execution_role. Name equals SageMaker_execution_role. Assume_role_policy equals JSON encode. Version: October 17, 2012. Statement: Action: STS assume role. Effect: allow. Principle: Service: SageMaker.amazonaz.com. Inline_policy. Name equals SageMaker_policy. Policy equals JSON encode. Version: October 17, 2012. Statement: Effect: allow. Action: S3. Logs. Resource: run Terraform init to initialize the working directory, and Terraform apply to provision the notebook instance. Step 2. Model preparation and inference scripting within the notebook. Once your SageMaker notebook is up and running, it's time to prepare your Hugging Face model. Start by cloning the model repository and installing the necessary libraries. !pip install transformers Boto 3. Next, load your Hugging Face model in Tokenizer and write an inference script to handle predictions. From transformers import pipeline. Model equals pipeline text classification. Model equals Distilbert base uncased. Def predict text. Return model text. This script can be further customized to meet your specific use case. Save the script within the notebook for future use. Step 3. Model compression and secure uploading to S3. With your model and inference script ready, the next step is to compress the model artifacts and upload them to an S3 bucket. This allows SageMaker to access the model during deployment easily. Compress the model files. !tar czvf model.tar.gs model/. Upload the compressed model to an S3 bucket. Import Boto3. S3 equals Boto3.client S3 upload_file model.tar.gs, your S3 bucket name, models/hugging face/model.tar.gs. Ensure your S3 bucket is configured with proper access controls to maintain security. Step 4. SageMaker Endpoint Creation, IAM roles, policies, and configuration. The final step is to create a serverless SageMaker endpoint to serve your Hugging Face model. Update your Terraform configuration to include the necessary resources. Resource AWS_SageMaker_model Hugging Face_model. Name equals Hugging Face model. Execution_role_arn equals AWS_IAM_role.SageMaker_execution_role.arn. Primary_container. Image equals 7631043518884. dkr.ecr.us west2.amazonoz.com/Hugging Face PyTorch Inference 1.9.0 CPU Pi38 Ubuntu 20.04. Model_data_URL equals S3:/ your S3 bucket name /models/Hugging Face/model.tar.gs. Resource AWS_SageMaker_endpoint_configuration Hugging Face_endpoint_config. Name equals Hugging Face endpoint config. Production_variants. Variant_name equals all traffic. Model_name equals AWS_SageMaker_model.huggingface_model.name. Initial_instance_count equals 1. Instance_type equals ml.m5.large. Resource AWS_SageMaker_endpoint Hugging Face_endpoint. Name equals Hugging Face endpoint. Endpoint_config_name equals AWS_SageMaker_endpoint_configuration.huggingface_endpoint_config.name. Apply the changes using Terraform Apply, and your serverless endpoint will be up and running. Conclusion: streamline NLP model deployment with serverless SageMaker. Following this podcast, you've successfully deployed a Hugging Face model on Amazon SageMaker using serverless endpoints and Terraform. This approach simplifies the deployment process and ensures scalability and cost efficiency, making it ideal for production-grade NLP applications. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.